Okay, time for ellipses. This first overview of ellipses is going to be very simple. We're going to skip some stuff and come back to it tomorrow. For ellipses, instead of being all the points the same distance away from a center, like in a circle, that's a terrible circle, but you get my point. All of these points are the same distance away. Ellipses have two focal points, or foci, and the ellipse is all the points, the sum of whose distances from those two foci are the same. So what these two distances add up to is the same as what these two distances add up to, or what these two distances add up to, or they would be if I could draw better. That's how you define an ellipse. So an ellipse doesn't just have one radius. It sort of has two. So let me draw another ellipse over here. From the center point, you can think of it as having one radius vertically and one radius horizontally. So that means we need two numbers. So here is the standard form for an ellipse. A is always considered to be bigger. You don't need to worry about that for today. That'll come up again tomorrow. The x and y may be in either order. And the term under the x, if you take the square root of that, that will be your horizontal radius. And the term under the y, the square root of that will be your vertical radius. So we are not going to work on putting this in standard form for today. I'm just going to give you the standard form, and then we are going to work on how to graph the ellipse from that standard form. So here is the standard form. As you can see, the ellipse is already graphed for you. So from the standard form, the h and k work just the way they did for a circle. The center is at -3, +2, right there. Now, the 9 is under the x, so this is what we're going to use to get our horizontal radius. Sometimes it will be called the semi-major axis. For today, I'm just going to call it the horizontal radius. So the horizontal radius is the square root of the number under the x. So the horizontal radius is 3. From the center, they're going 3 to the right and 3 to the left. The number under the y is the vertical radius. I'm sorry, I just realized. Sometimes it's the semi-major axis, sometimes it's the semi-minor axis. This, again, is something we'll get into later. You don't have to worry about it for today. The vertical radius here will be 2, square root of 4. From the center point, they go up 2 and down 2, and that's it. Don't worry about any of this for now. Don't worry about finding foci. Don't worry about A, B, or C. Just finding the center and graphing those 4 points. So on the back of the page, oh, hey, my marker bled through. Oh well. Here is our ellipse. As I said, we're not going to worry about foci for right now. The center is at 2, -4, so just like a circle, we can do that part right now. Y + 4 squared. And you've always got equal to 1. Now I got to figure out these bits. From the center, horizontally to the outside, going from 2 to 8, that's 6 steps. So what goes under here will be 6 squared, or 36. Vertically from the center to the outside, from -4 to -7, that's 3 steps. So under here will be 3 squared. So the equation is x - 2 squared over 36 plus y + 4 squared over 9 equals 1. And that's it. If you are asked to find the things and graph them, very simple, except you got to look out for this. Some textbooks put the y first if it has the larger radius. So look out for it because that might mess up your center point. So we're going to use this equation. We're going to find the coordinates of the center. we're skipping the foci for right now, and the vertices, and we're going to graph it. The center, here's my x. So the center is at -4, +3. So just be careful when they write these in the opposite order. So -4, +3, there's my center point. Under the y, we've got 25. So that means we're going to go up and down 5, because that's the square root of 25. So from the center point, we'll go up 5, and down 5. 1, 2, 3. So that gives me vertices of -4, +8, and -4, -2. And under here, the 9, that gives me my horizontal axis. So we're going to go left and right. Square root of 9 is 3. Left 3, right 3. So sometimes it's called covertices, are, because it's the shorter way, -7, 3, and -1, 3. You'll notice in these two the x stays the same as the center point, and in these two the y stays the same as the center point. That's it. That's really all you need to graph your ellipse. I still can't draw. But that's all you need to know for right now. How to find the coordinates of the center from the standard form of the equation, and how to use these denominators to find the 4 vertices and sketch the graph. And that's all. Everything else we'll talk about later.